Okay, let's unpack this. We are diving deep today, really getting into the hiring criteria for, let's say, elite Python developers.
Yeah.
And this isn't just about, ticking boxes on a resume. We're trying to sort of reverse engineer how top tech interviewers think.
That's absolutely the mission here. We've got this detailed interview profile. It breaks down qualities, the CS fundamentals,
Yeah,
and some really specific Python questions.
the kind that separate the good from the great.
Exactly. It's about understanding not just the technical skills, but the why. That intellectual curiosity, the solid foundation, that's what makes a candidate stand out.
Okay, so let's start where the source does, which is, maybe surprisingly, not with code. It's more about the broader qualities.
Yeah, what's fascinating is how it grounds everything first. Even for these super technical roles, they stress universal stuff.
Yeah.
Are they willing to learn? Do they actually have the skills they claim? And crucially, is their passion for the job itself.
Right. They want the whole picture, something that goes way beyond just like college grades. So it sounds like they're looking for ongoing active learning.
Yeah.
How do they actually check that? You can't just say you're curious.
Oh, exactly. You have to show it.
Yeah.
So they ask how candidates stay current. They look for actual evidence.
Like what specifically?
Like, who do you follow on Twitter? Which tech blogs are you actually reading? What's a technical book you found interesting recently, and why?
Ah, okay. So it proves learning isn't just a thing you did once. It's continuous.
Precisely. It's not something that just stopped when you got your diploma.
And this interest, it needs to be backed by action, right? It's not enough to be passionate. You got to build stuff.
Absolutely. The commitment, it needs to be visible. Like, is their GitHub profile active? Have they maybe contributed to open source?
Yeah, right.
Even things like hackathons, that sends a pretty strong signal. And the source explicitly mentions asking about side projects.
Why single out something like game development, though? If someone's building complex web backends, doesn't that already show they can build?
That's a fair question. And yeah, web dev is important, practical stuff. But something like game dev, or maybe a cool data visualization, it often proves a couple of things at once.
Okay, like what?
Well, first, it shows they can manage complexity outside of a structured work project. And second, it often pushes them into areas like GUIs, maybe complex state management, different kinds of algorithmic challenges.
Stuff they might not hit in their day job.
Exactly. It shows they build because they enjoy it, because they're exploring, building for the joy of it.
Okay, so you establish that spark, that curiosity, but then, the foundation needs to be rock solid, computer science fundamentals.
Non-negotiable. That's what turns a decent coder into someone who can actually engineer systems.
So what are the core CS things they're checking for here in this section 2?
Well, the expectation is really understanding basic algorithms, concepts, The discussion usually revolves around efficiency.
Efficiency.
Yeah, how would you find data? How would you process it, sort it, especially when you're talking about large scale? It means really getting the trade-offs, time versus space complexity.
So it's not just, can you write the code, but more like, why is this algorithm better than that one for this particular problem?
Precisely. And it stretches beyond just algorithms. It includes having a decent grasp of databases, SQL, NoSQL, and having a structured way to think about modeling.
Modeling data systems.
Yeah. If you can't map the real world into sensible, stable data structures, well, you're going to struggle building stable software.
Makes sense. And the source gave us 2 specific CS questions they actually use. The first one sounds like a classic.
It is. Using pseudocode, reverse a string. First iteratively, then recursively.
Okay, iterative seems straightforward loops, maybe swapping characters. What does the recursive part really test?
The recursive solution, that's often the real insight. It checks if they genuinely understand recursion, how the call stack works, that kind of conceptual thinking. If they stumble on the base case for recursion.
It might indicate a weaker grasp of those core concepts.
You could, yeah. It suggests their foundational thinking might need work.
And the second CS question. It's about testing, right?
Yes, defining the difference between a good unit test and a good functional test. This is crucial for professional work.
Why is that distinction so important?
Knowing the difference, it just shows maturity. A unit test focuses on the smallest possible piece of code, isolating it, often using mocks.
So if it fails, you know exactly where the problem is.
Exactly. Functional tests, though, they test a whole workflow, an end-to-end process. They make sure the integrated parts work together. If someone mixes those up.
It suggests they might not fully get test-driven development or how to build reliable software systematically.
Right. Their understanding of the whole testing lifecycle might be a bit immature.
Okay, that's a perfect transition. Once the CS basics are covered, the focus shifts. It zooms right into Python itself, its quirks, its mechanics. This is where Section 3 gets really interesting and technical. Yeah, this is the deep dive into the role specifics. And the first concept is a big one. It touches on memory, how functions handle data. Do arguments in Python get passed by reference or by value? Okay, I feel like this one's a classic trick question almost, because the answer isn't just a simple yes or no, is it?
It really isn't. It's more nuanced. Python technically uses what's called pass-by-object reference.
Pass-by-object reference. What does that mean in practice?
Well, the key thing is whether the object being passed is mutable or immutable. For immutable things like numbers or strings, it acts like pass-by-value. Changes inside the function don't affect the outside.
Okay.
But for mutable objects lists, dictionary changes you make inside the function do persist outside, and that looks a lot like pass-by-reference.
So a top candidate needs to explain that difference based on mutable versus immutable.
Absolutely. They need to show they understand Python's underlying memory model, not just recite a rule.
Got it. That clarity is key. Another question that seems to probe deeper understanding is asking why functions are considered first-class objects in Python. What does that actually mean?
It basically means functions are treated just like any other piece of data. You can assign them to variables, you can store them in lists or dictionaries, pass them into other functions, or even return them from other functions.
Right. So, practically speaking, that's what allows for powerful patterns like, say, writing decorators or using higher order functions.
Precisely. That unlocks a whole level of functional programming style in Python. If they can talk about, closures or building custom decorators, it shows they really grasp the language's structure, not just the syntax.
And then there's the practical side, the tools. They ask what tools candidates use for things like linting, debugging, profiling.
Yeah, this checks for workflow maturity.
Well,
Linting, for example, using tools to check code style and quality before you even run it. Profiling, understanding why code is slow, and having tools like maybe cProfile to actually pinpoint bottlenecks.
it shows they have professional habits.
Exactly. Mature development habits. Okay, moving further into functional ideas. They expect people to know standard idioms, like using filter or reduce on iterables. Definitely. And comprehensions are huge here. What are list comprehensions, dict comprehensions?
Why are those so important in Python?
Well, they're often much more concise, more readable, and sometimes significantly faster than writing out traditional for loops to achieve the same result. If someone always defaults to a for loop when a comprehension is cleaner,
It might suggest they haven't fully absorbed the idiomatic Python way.
yeah, it's a potential sign they haven't quite internalized that Pythonic style. And the classic structure comparison, what's the difference between a list and a tuple?
Right. The basic answer everyone gives is mutability lists can be changed, tuples can't.
But there's more to it. Oh, yeah. The elite answer connects that mutability difference to real-world implications. Things like performance tuples are generally faster. Memory usage tuples take up less space. And even thread safety sometimes. Tuples are often better for holding fixed collections of items, especially heterogeneous data, or when you want to guarantee something isn't accidentally modified.
Okay, that makes sense. So now we move into section 4. This is where they seem to pose the trickiest questions, the ones that test how candidates deal with ambiguity or complex internal stuff, proving they can apply knowledge, not just memorize it. Yeah, this is definitely where they separate the wheat from the chaff, so to speak. The first challenge mentioned is quite practical, actually. Implement the Linux where is command.where #as. That finds the binary, source, and manual pages for a command, right? Sounds straightforward, but what's the hidden challenge there?
It tests a surprising range of systems-level skills. You need to navigate the file system effectively, probably search through multiple directories defined in the system's path environment variable, maybe use recursion, maybe OS-specific modules. It involves path manipulation, potentially running sub-processes. It's a solid test of practical system interaction in Python.
Okay, definitely more involved than it sounds. And sticking with that functional maturity theme, there's the closure question. What does it mean when we say a Lambda expression forms a closure?
Ah, closures. This gets right to the heart of understanding scope in Python. A closure happens when a function, even a tiny anonymous lambda, remembers the environment it was created in. It holds on to variables from its enclosing scope, even if that outer scope is finished executing.
So it tests if they understand how Python manages variable lifetimes beyond just local and global.
Exactly. How does Python keep track of variables that aren't strictly local but aren't global either? Closures are key to that.
Right. And finally, we hit these code output puzzles. These seem designed to catch people who haven't quite internalized Python's specific execution rules. Let's start with the slicing one.
Okay. You have a list. List A, B, C, D, E. Then you run print list 10. What happens? What's the output? Yeah, someone newer to Python might guess it throws an index error because index 10 is way out of bounds.
It doesn't. Nope. Python slicing is deliberately designed to be forgiving, to be safe in this way. If the start index is beyond the end, it just gracefully returns an empty list.
Okay. And knowing that is important
because production code often relies on that safe behavior. You don't always need explicit boundary checks when using slices like that.
Gotcha. Okay, now for the final puzzle. This one looks the most complex. It's about class variables and instance variables interacting. There's a class C that has a variable dangerous equals 2. Then we create two instances, C1 and C2. Let's walk through this sequence slowly because it seems really revealing. Absolutely. This sequence is gold for testing object model understanding. So initially you create C1 and C2. If you print C1.dangerous, what do you get?
Well, C1 doesn't have its own dangerous yet, so it looks up to the class. It should print 2.
Correct.
It finds the shared class attribute. Now, the crucial step, C1.dangerous equals 3. What does this do? Does it change the class variable?
No. And this is the key. When you assign to an attribute on an instance like this, C1.dangerous equals, Python doesn't modify the class attribute. Instead, it creates a brand new instance attribute just on C1.
So C1 now has its own dangerous attribute that's hiding the class 1.
Exactly. It shadows the class attribute. So now print C1.dangerous will give you 3.
Okay, but C2 wasn't touched. So if we print C2.dangerous...
it still sees the original class attribute. So print C2.dangerous outputs 2.
Right, because it never got its own instance attribute. Okay, now the really interesting part. Del C1.dangerous. We delete the instance attribute we just created. Yep.
Now what happens if we try to print C1.dangerous again? Is it an error because we just deleted it? That's a very logical guess. But this tests knowledge of Python's attribute lookup order, often called MRO method resolution order. But it applies to attributes too. When Python can't find dangerous directly on the instance C1 anymore,
it searches upwards.
To the class. Exactly. It immediately finds the shared class attribute CDangerous again. So print C1.dangerous after the del statement goes back to printing 2.
Wow, okay. The deletion just uncovers the class attribute again.
Precisely. The instance shadow is gone, so the lookup falls back. And the final step really confirms this sharing. You directly modify the class attribute. CDangerous equals 3.
Right.
We change the shared value itself.
So now what happens when we print C2.dangerous?
Well, C2 never had its own instance attribute. It was always looking at the class attribute. And C1 is also now looking at the class attribute again. Since its instance 1 was deleted, we just changed that class attribute to 3.
So print C2.dangerous now prints 3.
Correct. That whole sequence, shadowing with an instance variable, deleting it to reveal the class variable again, then modifying the class variable directly, it thoroughly tests if a candidate truly understands how instance and class attributes interact in Python.
Okay, so wrapping this all up, what's the big picture for you listening to this? Whether you're prepping for an interview or just want to understand what elite looks like, it seems clear it's this balance.
Yeah, it's a balance.
Solid CS foundations, that demonstrated curiosity at GitHub, the side projects, and then this really nuanced, deep grasp of Python's own specific behaviors.
Things like first-class functions, how memory works with mutable versus immutable types, and yeah, the nitty-gritty of class attribute mechanics.
We've definitely seen that these interviews, or at least this profile of one, they're designed to really push the boundaries. It's not just, do you know this function exists, but how does it work? Why does it work that way?
Exactly. Probing the limits, understanding the under-the-hood stuff, how behavior changes with context like parameter passing or that attribute resolution we just walked through.
Right. We spent a good bit of time on that class variable puzzle, the whole shadowing and deleting dance. So here's a final thought for you to chew on. If a candidate gets stuck after that del C1.dangerous step, if they can't predict that it falls back to the class attribute, what fundamental assumption are they missing? What wires are crossed in their mental model about the difference between shared class attributes and overriding instance attributes?
That inability to distinguish clearly between sharing and shadowing, that's probably your next deep dive into Python's object model.